When people think about exploration, they usually imagine space. Rockets, astronauts, distant planets. But surprisingly, the deep ocean remains far less explored than space. Scientists estimate that more than 80% of the world's oceans are still unmapped and unexplored. Beneath the surface lies a vast and mysterious world, a realm of total darkness, crushing pressure, and strange lifeforms that seem almost alien. One of the most famous places in this underwater world is the wreck of the RMS Titanic. Since its discovery in 1985, the Titanic has fascinated historians, scientists, and explorers alike. Resting nearly 3,800 meters below the North Atlantic, the wreck sits in a place where sunlight never reaches and pressure is so extreme that ordinary machines would be crushed instantly. For decades, only a handful of highly specialized scientific submersibles were capable of reaching it. But in the early 2000s, a new idea began to emerge. What if ordinary civilians could visit the Titanic? What if deep-sea exploration could become a tourist experience? That idea eventually gave birth to a company called OceanGate. OceanGate was founded in 2009 by entrepreneur and engineer Stockton Rush. His vision was ambitious: make deep-sea exploration more accessible by building new types of submersibles. Rush believed traditional submersibles were too expensive and too conservative in their design. He wanted to introduce innovative materials and engineering concepts that could dramatically reduce costs. His most ambitious project was a submersible called Titan. Titan was designed to take passengers nearly 4 kilometers beneath the ocean surface to visit the Titanic wreck. Unlike most deep-sea vehicles made entirely from steel or titanium, Titan used a carbon fiber pressure hull combined with titanium end caps. This unusual design was intended to make the submersible lighter and cheaper to build. OceanGate marketed the experience as an exclusive expedition, not simply a tourist trip. Participants were called mission specialists, and each seat on the submersible cost around $250,000. For wealthy explorers and adventurers, the opportunity was irresistible. Few people on Earth had ever seen the Titanic with their own eyes. Titan promised to change that. In June 2023, OceanGate launched another Titanic expedition from the North Atlantic. The support vessel Polar Prince carried the Titan submersible and its crew to the dive site, located southeast of Newfoundland, Canada. On June 18, 2023, 5 people climbed inside Titan for what was expected to be another routine descent to the wreck. Inside the submersible were Stockton Rush, the CEO of OceanGate and pilot of the mission; Paul-Henri Nargeolet, one of the world's most experienced Titanic explorers; Hamish Harding, a British billionaire adventurer known for extreme expeditions; Shahzada Dawood, a Pakistani-British businessman; Suleiman Dawood, his 19-year-old son. The interior of Titan was surprisingly simple. Passengers sat cross-legged on the floor inside a small cylindrical chamber about the size of a minivan. There were no traditional seats, and only a few controls. Navigation was done using a touchscreen interface, and the submersible was controlled partly using a modified video game controller. Once the hatch was sealed from the outside, the crew had no way to exit until the sub returned to the surface. Despite the unconventional design, Titan had already completed several dives in previous years. The mission seemed routine. Shortly before 9 a.m., Titan was lowered into the Atlantic Ocean and began its slow descent toward the Titanic wreck far below. For the 5 people inside, the journey promised to be the adventure of a lifetime. But somewhere in the cold darkness of the deep ocean, something would go terribly wrong. And within hours, the world would be asking a chilling question. What really happened to Titan at 3,800 meters? On the morning of June 18, 2023, the submersible Titan was carefully lowered from the support ship Polar Prince into the cold waters of the North Atlantic. The sea was calm, and conditions appeared ideal for the dive. Once in the water, the small vessel began its slow journey downward. Inside the submersible, the 5 occupants sat close together in a cylindrical compartment roughly 6.7 meters long and less than 2.8 meters wide. There were no seats in the traditional sense. Passengers sat on the floor with their backs against the curved interior walls. In front of them was a small acrylic viewing window, only large enough for one person at a time to look through. Through that tiny port, the explorers hoped to glimpse the most famous shipwreck in history. The descent toward the Titanic would take about 2 hours. Communication between Titan and the surface ship did not occur through radio signals, which cannot travel through deep water. Instead, the submersible used a special acoustic communication system that transmitted short text messages through sound waves. Every 15 minutes, the crew would send updates confirming their status. At first, everything seemed normal. As Titan descended deeper, the environment outside changed dramatically. Within a few hundred meters, sunlight began to fade. By 1,000 meters, the ocean had turned completely black. This region of the ocean is known as the midnight zone, where sunlight never penetrates. Outside the submersible, the temperature hovered just above freezing. But the real danger was pressure. At sea level, humans live under 1 atmosphere of pressure. At the depth of the Titanic, the pressure is about 380 atmospheres, the equivalent of having the weight of a fully loaded commercial jet pressing on every square meter of the hull. The Titan submersible was designed to withstand these immense forces. Its cylindrical body was constructed from layers of carbon fiber composite, a material widely used in aerospace engineering for its strength and lightweight properties. On each end of the cylinder were titanium hemispheres, designed to seal the pressure hull. However, carbon fiber behaves very differently from metals when subjected to repeated pressure cycles. While titanium can deform slightly and still maintain integrity, carbon fiber can develop tiny internal fractures that are nearly impossible to detect from the outside. Some engineers had warned that using carbon fiber for such extreme depths was risky. But on this dive, those concerns were far from the minds of the passengers. They were descending toward one of the most legendary locations on Earth. As Titan continued its descent, it maintained regular communication with the surface ship. The crew sent short messages confirming that everything inside the submersible was operating normally. Roughly 1 hour and 45 minutes into the dive, Titan had already traveled more than halfway to the Titanic wreck. Then the submersible transmitted what would become its final message. The exact content of that message has not been publicly detailed in full, but investigators confirmed that it indicated the sub was continuing its descent. Moments later, the communication signal suddenly disappeared. At first, the support crew aboard the Polar Prince was not immediately alarmed. Temporary communication losses can happen in deep-sea operations due to interference, equipment glitches, or signal distortion caused by underwater terrain. The crew attempted to re-establish contact. They waited. Minutes passed. Then more time passed. Still nothing. Normally, Titan would continue descending until reaching the Titanic wreck, where the crew would spend several hours exploring before returning to the surface. But the submersible also had another tracking system that monitored its position. That signal was now gone as well. Something had clearly happened. By the afternoon of June 18, Titan had failed to reappear on the ocean surface. As concern began to grow, authorities were notified. What started as a routine exploration mission was quickly becoming a major international search and rescue operation. And somewhere nearly 4 kilometers below the surface of the Atlantic Ocean, the fate of Titan remained unknown. The world would soon begin watching closely as rescuers raced against time to find the missing submersible. But what they would eventually discover on the ocean floor would reveal a far more devastating truth than anyone had imagined. When Titan failed to return to the surface on June 18, 2023, concern quickly turned into alarm. The support vessel Polar Prince had lost both communication and tracking with the submersible during its descent. Hours passed with no signal and no sign of the vehicle. Soon, authorities were notified, and one of the most intense deep-sea search operations in modern history began. The United States Coast Guard, the Canadian Coast Guard, and several international organizations launched a coordinated rescue mission in the North Atlantic Ocean. Aircraft, ships, sonar systems, and underwater robots were mobilized to locate the missing submersible. The challenge was enormous. The search area covered thousands of square kilometers of open ocean. The sea itself was over 3,800 meters deep, darker than night and cold enough to slow nearly all mechanical operations. But rescuers faced another terrifying reality. Titan was equipped with only about 96 hours of breathable oxygen. If the submersible was still intact and stranded on the ocean floor, the crew inside would have only 4 days before the air supply ran out. This meant every minute counted. Around the world, news networks began reporting the unfolding situation. Social media exploded with speculation, concern, and hope. The question on everyone's mind was simple. Was Titan still intact somewhere beneath the Atlantic? As the search intensified, sonar-equipped aircraft began scanning the ocean for unusual sounds. Then something unexpected happened. Rescue teams reported detecting intermittent knocking noises coming from deep underwater. The sounds appeared at roughly regular intervals, sometimes about every 30 minutes. Immediately, speculation began. Some experts suggested the noises might be coming from the Titan submersible itself. If the crew were alive but trapped, they might be banging on the hull in an attempt to signal rescuers. This possibility electrified the rescue effort. Ships rushed to the area where the sounds were detected. Sonar systems were focused on pinpointing the source of the noises. Around the world, millions of people followed the story in real time. For families of the passengers, those reports brought a fragile sense of hope. If the knocking truly came from Titan, it could mean the crew was still alive. But the ocean is a place filled with strange acoustic signals. Ships, marine animals, underwater currents, and even shifting rocks can produce sounds that travel long distances through water. Investigators later determined that the noises detected during the search were not connected to the Titan submersible. But at the time, no one knew that yet. And hope continued to drive the search. As time passed, rescue teams began deploying more advanced equipment capable of reaching the deep seafloor. Specialized remotely operated vehicles, or ROVs, were transported to the search area. These robotic submarines are designed to operate at extreme depths where human divers cannot survive. Guided by cables from ships above, the ROVs slowly descended through the dark water. Nearly 4 kilometers below the surface, the seafloor around the Titanic wreck is a silent and eerie landscape. The Titanic itself rests there like a rusting ghost ship, slowly being consumed by deep-sea bacteria. Somewhere in that vast darkness, rescuers hoped to find Titan intact. If the submersible had simply lost power or become entangled in debris, it might still be possible to rescue the passengers. But time was running out. Every passing hour meant less oxygen inside the sub. Finally, on June 22, 4 days after Titan disappeared, one of the robotic vehicles scanning the seafloor detected something unusual. Scattered pieces of debris. The fragments were located only a few hundred meters from the Titanic wreck. As investigators examined the objects through the robot's cameras, the grim reality began to emerge. Among the debris were recognizable components of the Titan submersible. The tail cone, sections of the pressure hull, and pieces of titanium structure. Within moments, experts understood what the debris pattern meant. Titan had not simply lost communication. It had suffered a catastrophic implosion deep beneath the ocean's surface. The tragedy had likely occurred almost instantly during the descent. And the discovery would soon reveal the terrifying power of the deep ocean. On June 22, 2023, 4 days after the Titan submersible disappeared, a remotely operated vehicle exploring the seafloor made a grim discovery. The robotic cameras detected scattered debris lying roughly 300 meters from the wreck of the Titanic. At first, the shapes were difficult to identify in the darkness. The seafloor at that depth is covered with sediment, rust particles from the Titanic, and scattered metal fragments from decades of exploration. But as the cameras moved closer, investigators began recognizing specific components. They found the tail cone of the Titan submersible, followed by pieces of titanium structure that had once been part of the vehicle's frame. Nearby were fragments believed to belong to the pressure hull itself. The debris field was not concentrated in one place. Instead, parts were scattered across the seabed. To experienced deep-sea engineers, this pattern revealed a devastating truth almost immediately. Titan had suffered a catastrophic implosion. Unlike an explosion, where pressure moves outward, an implosion happens when overwhelming pressure crushes an object inward. In the deep ocean, the surrounding water pressure is so immense that if the hull of a submersible fails, the collapse occurs instantly. Within minutes of the discovery, the U.S. Coast Guard confirmed the worst. The Titan submersible had been destroyed. To understand what happened to Titan, it helps to understand the forces involved at extreme ocean depths. At the surface of the Earth, we experience only one atmosphere of pressure. It is gentle enough that we hardly notice it. But for every 10 meters of depth in the ocean, pressure increases by roughly 1 atmosphere. At the Titanic wreck site, about 3,800 meters deep, the pressure reaches approximately 380 atmospheres. That means every square inch of Titan's hull was being pushed by a force of nearly 6,000 pounds. The total pressure on the submersible was equivalent to the weight of several large airplanes pressing down on it simultaneously. The entire safety of the crew depended on one thing: the structural integrity of the pressure hull. If that hull developed even a tiny failure, a crack, separation, or structural weakness, the surrounding water would rush inward with incredible speed. In such a situation, the collapse happens in milliseconds. The pressure equalizes instantly, destroying the vessel before any human reaction is possible. Investigators believe that is exactly what happened to Titan. The submersible was likely descending normally when the hull suddenly failed. In less than the blink of an eye, the vessel was crushed by the surrounding ocean. One of the most difficult questions investigators faced was what the passengers might have experienced during the final moment. Experts in deep-sea engineering and human physiology examined the physics of such implosions. Their conclusion was clear. The collapse would have occurred faster than the human brain can process information. When the hull failed, the surrounding water pressure would have forced the structure inward instantly. The energy released during that collapse would have destroyed the interior environment in an extremely small fraction of a second. This means the occupants likely never realized what was happening. There would have been no time for fear, no time for awareness, and no prolonged suffering. The implosion would have been over before the brain could register the event. While that fact offers some small comfort, it does not change the scale of the tragedy. 5 lives were lost during a mission that had promised exploration and discovery. But even after investigators confirmed the implosion, a critical question remained unanswered. Why did Titan fail in the first place? Because in the world of deep-sea engineering, catastrophic failures rarely occur without warning. And as investigators soon discovered, the story of Titan included warnings that had been raised long before the final dive ever began. After investigators confirmed that Titan had suffered a catastrophic implosion, attention quickly turned to one crucial question: why did the submersible fail? One of the most debated aspects of Titan's design was its pressure hull. Most deep-sea submersibles capable of reaching extreme depths are built from thick steel or titanium, materials known for their predictable behavior under pressure. These metals can bend slightly without suddenly breaking, allowing engineers to detect stress and fatigue before a catastrophic failure occurs. Titan, however, used a different approach. Its main body was constructed from carbon fiber composite, a material commonly used in aircraft and racing cars because it is extremely strong and lightweight. Carbon fiber works exceptionally well in environments where forces pull or stretch the material. But the deep ocean is a completely different environment. At depths of nearly 4 kilometers, pressure is not pulling outward, it is crushing inward from every direction. Under these conditions, carbon fiber can develop tiny internal fractures that are difficult to detect. Over time and repeated dives, these microscopic weaknesses can grow. Eventually, they may lead to sudden structural failure. Some engineers had warned that using carbon fiber for a deep-sea pressure hull at such depths was experimental and potentially dangerous. Long before the Titan disaster, concerns had already been raised within the deep-sea engineering community. Several experts questioned whether Titan's design had undergone enough independent safety testing. Unlike many scientific submersibles, Titan was not certified by major marine classification organizations, which normally review and approve pressure vessels designed for extreme environments. In 2018, a group of engineers from the submersible industry reportedly expressed concern in a formal letter to OceanGate. They warned that the company's experimental approach could lead to catastrophic failure. Some former employees also spoke publicly about safety concerns, suggesting that the vessel required additional testing before carrying passengers to such extreme depths. OceanGate leadership, however, believed innovation required breaking away from traditional engineering constraints. Stockton Rush, the company's CEO, often spoke about how safety regulations could slow technological progress. He believed Titan represented the future of deep-sea exploration. For several years, the submersible completed dives successfully. But the ocean does not forgive structural weaknesses. And eventually, those warnings proved tragically accurate. The loss of Titan shocked the world not only because of the tragedy itself, but also because it raised serious questions about private exploration in extreme environments. Deep-sea exploration has always carried risks. The ocean is one of the most hostile environments on Earth, with crushing pressure, freezing temperatures, and total darkness. For decades, governments and research institutions operated deep-sea submersibles under strict engineering standards and safety certification. The Titan disaster forced regulators and scientists to reconsider how privately developed exploration vehicles should be monitored. Many experts now argue that future deep-sea tourism must follow much stricter safety guidelines, especially when experimental technologies are involved. At the same time, the tragedy also reminded the world of something profound. Despite all of humanity's technological achievements, the deep ocean remains a place of immense power and mystery. At 3,800 meters beneath the Atlantic, where the Titanic rests in silence, nature's forces are stronger than any machine built by human hands. The story of Titan is ultimately a story about ambition, innovation, and risk. It is a reminder that exploration will always push the boundaries of technology, but those boundaries must be respected. Because in the depths of the ocean, even the smallest engineering mistake can have irreversible consequences. And the question that began this story, what really happened to Titan at 3,800 meters, now has an answer. It was not a mystery of the sea. It was a tragedy shaped by physics, engineering, and decisions made long before the final dive ever began.
Subscribe Info Beyond Borders now for more mind-blowing knowledge.